Hello everyone. Myself Usha Mirajkar, Selection Grade Lecturer, Electronics and Communication Department, Government Polytechnic, Belgaum. Once again, welcome back to the sessions on the Advanced Communication. This is the 8th session on the Unit 2 here. The contents which we are going to cover in this particular session are, that is the antenna tracking here. In the last session, we have studied about the antenna scanning. Now this is the antenna tracking. What do you mean by the antenna tracking? That is the antenna scanning and the antenna tracking both are related to each other. Scanning means what? To search in the particular region there for the target, whether any target is present or not there. For example, now see here in the given region here, suppose this is the given region here, in this region, to search the target here, so from the particular antenna we are radiating, we are scanning the region here. Scanning means what? To finding the or to searching the target here. Therefore, wide fan shaped beam here, that is very wide fan shaped beam signal is radiated such that it will cover the large amount of area at a single time, and for the target it is searched here whether any target is there or not. Now for example, consider here one target is located. Suppose this is one target is present here. Now we have to follow this particular target here. Suppose this target is moving continuously, it is moving, the target is moving. Now to follow this one, we cannot use this wide fan shaped beam here, because it is not locating on that particular target, but it is covering the full region here. Therefore, once the target is searched or once the target is located, afterwards instead of the pencil fan shaped beam, they will make use of the pencil type of or the very narrow beam width signal here. Very narrow here, sharp beam is used such that continuously it is following that particular target. Wherever the target moves here, continuously this our signal, radar signal is following there. Therefore, that process is called as the tracking here. That is, in case of the scanning, the wide fan shaped beam is used to cover the region. Once the target is located, once the target is detected there, to follow that particular target continuously, very narrow beam is applied here, and that will continuously follows the particular target here. That following that particular target continuously, that is called as the antenna tracking here. That is called as the antenna tracking. That is, to locate and follow the movements of the target very accurately. Antenna tracking is used here. In the tracking mode, the antenna is dedicated to one target and automatically follows its changing direction. Means it is not spreaded, the beam is not spreaded in all the direction. It is not covering full region here. But the beam is dedicated to one particular target here. It is focused on one particular target, and continuously it is following that particular target wherever it is direction is changing. How the target is moving, in the same fashion the antenna beam is also moving here. That is called as the antenna tracking here. Now the type of the antenna tracking, that the types of the antenna tracking. Again, in the antenna tracking method, we are having the different types here. Based on the applications, those types are used. Antenna tracking, we are having the different types. First one, the lobe switching technique here. The lobe switching technique. Second is the conical scanning. Next is the monopulse tracking here. These are the three different types of the tracking methods. Those are used in the radar. Now one by one we will study here. First one is the lobe switching, or it is also called as the sequential scanning here. Lobe switching technique is also called as the sequential scanning to follow the particular target here. Now how it works? That is, the main principle here used is if the antenna beams are switched between two patterns, or the antenna beam is switched between the two positions here, such that from both the positions echo signals are received, and those echo signal strengths are compared here. Depending on that, the movement of the antenna will take place, and exactly when both the echo signals are same, that indicates the and that particular target is exactly midway between those two positions here. Therefore, if the antenna beams are switched between two patterns alternatively for the tracking the target, then it is called as the lobe switching or the sequential scanning here. That is, this technique is used to find the angular error in one coordinate. In one coordinate, we can get the angular error. That is how much it is deviated from that particular given axis here. That we can find out in only one coordinate here. That is the how the procedure here. The direction of the antenna beam is rapidly switched between two positions here. It is rapidly switched. Antenna is in first one time it is one position, again next time it is second position, like this. For example, just observe here. Suppose this is the antenna here. Suppose this is the antenna here, radar antenna. Now it is radiating the signal here. It is radiating that particular beam shaped narrow beam. It is radiating towards, suppose target is present here. It is moving continuously. It is moving continuously. For example, aircraft is there. It is moving continuously. Now suppose once it is detected the presence of the target, then what will happen? It has to track that one, where it is going. Now here in this lobe switching technique, first what they will do, in one position it is transmitted and the echo signal is coming back here. Echo signal is coming back. Again this is rotated to next position, or it is switched to next position here. Again from the next position, again the signal is radiated. Again that echo signal is received back here. This is the first position here. Again this is the second position of the antenna here. Therefore, first it is one position, it is radiated, again the echo signal is received. Again in the second position it is radiated and the echo signal is received. And these two echo signals, that is from first position and second position, those two echo signals are compared here, strength of the echo signals. If both are varying, suppose here the strength is more, at the second position strength is more, means what that indicates? The target is towards that second position. The target is towards that second position. Now suppose the target is the first echo signal is strength is more, means what that indicates? The target is nearer to the first position here. Therefore, depending on these two strength here, it is compared. And once both the echo signal strength are equal, when both are equal, then that indicates the target is exactly midway between the path here. Therefore, the target is exactly that can be accurately, it can be tracked here. This is the basic principle in the lobe switching or the sequential scanning or a tracking method here. That is, the direction of the antenna beam is rapidly switched between two positions, 1, 2, 1, 2, like this. Next, the strength of the echo from the target will fluctuate at a switching rate. How the antenna is switching from the one position to a second, again second to one, like this. The echo signal also fluctuates here. It is giving the echo signal, first it will be first position, again second position, first position and the second position, like this. It is fluctuating here. And when the target is exactly midway, when the target is exactly midway between the two directions, the echo strength will be the same for the both the antenna positions. Therefore, when it is exactly midway, both the strength will be equal there. Then that is indicated the target is exactly midway there. Thus, the target can be tracked with much greater accuracy. In this method, it can be tracked with a much greater accuracy here. Now, one of the main drawback or the disadvantage of this lobe switching is that is sequential lobing is only one plane only, means it will give the readings in only one plane. It is not able to give in horizontal and vertical, but it is giving in the readings in only one plane here. That is the main drawback here. That is if you observe this diagram here, this is the radar station, this is that particular antenna which is radiating that beam here. Now here, suppose for example our target aircraft is present here. Suppose this is the aircraft here at this position, correct? Now this is the position 1 and position 2. From here first it is taken and from here it is taken. Therefore, from the position 1 this is the echo signal here, and for position 2 this is the echo signal here. Then if you observe what is happening here, the strength here almost both are same here. Echo signal strength are both are same. Therefore, that indicates the target is exactly midway here. You can see the middle line here dotted exactly at that position here. Now just move to the second diagram here. Here what is happening? The target is closer to the position 1 here. First it is radiated in position 1, echo signal is received. Again it is switched to position 2, again the echo signal is received. Now the received echo signals are in the form of, suppose this is the position of the target here in the second time here. Now in the first position it is the strength of the echo signal, and in the second position this is the strength of the echo signal. Now just try to analyze here what is the conclusion here. That is, the first position strength is high compared to the second position here. Therefore that implies the target is closer to the first position. The target is closer to the first position here. Now if you observe to the next one here, that is here 192 again. Suppose again in the position 1 the target is particular echo signal is received. Again in this position 2 it is received here. Now in this case what will happen? It is closer to the position 2. Therefore which type of waveform will get here? In the position 1 it will be very small, but in the position 2 will get large here. This is the second position and this is the first position echo signal here. Therefore from this we can make out that at the second position the strength is large, means the target is towards the second position here. Therefore by the switching like this from the two positions here, the beam we can make out exactly accurately, we can track the target here. This is the lobe switching method here. Okay, next moving on to the next method, that is the conical scanning here. This conical scanning is nothing but it is the extension of the lobe switching only. That is, in case of the lobe switching or the sequential lobing method, what we did, we have switched the position of the antenna from two positions here, 1, 2 like that, and the echo signals are received and those are compared here. But here in the conical scanning, instead of switching between the two positions here, the antenna is slightly, it is taken out of the center axis here, and continuously it is rotated here. Continuously it is rotated and continuously the waves, that particular beams are radiated and the echo signals are received here. Again the strengths are analyzed, and depending on those echo signals here, it can be continuously tracked here. That is the main difference. In case of the lobe switching, only two positions, position 1, position 2, two pulses are transmitted here. But in case of the conical here, it is instead of two pulses here, it is continuously rotated here. The antenna is rotated and the pulses are transmitted. Therefore more than two pulses are required here. That is, in the conical scanning, the antenna beam continuously rotates for tracking the target. Then it is called the conical scanning here. A conical scan modulation is used to find the position of the target here. For the diagram, just see here, this is the antenna axis here. Slightly it is moved from the center, and afterwards it is continuously rotated here. Like this, it is rotated. From here also you can make out here. Here the axis here, afterwards it is rotated here. Then what will happen? The particular readings, echo signals are received, and depending on those strength here, we can make out and we can continuously track accurately the target here. This is the conical scanning method. The one of the limitation of the conical scanning is what? Motion of the antenna is more complex and additional servo motors are required here. Compared to the lobe switching, it is only two positions. Tuck you switch from 1 to 2, 2 to 1 like that. But in case of the conical, the motion is very complex here. The movement of the antenna is complex. Therefore, it requires some servo motors and all. Additional circuit is needed there. And also more than one pulse is required to locate a target accurately. One pulse is not sufficient. More than 1 or 2 pulses are required to continuously follow that particular target or to locate the target here. These are the disadvantages of the conical scanning here. And the advantage is what? The conical scanning system is accurate in both the horizontal and the vertical planes here. It is giving the reading in both the horizontal and the vertical planes, but compared to the lobe switching, it is accurate in only one plane there. That is overcome in this particular conical scanning method here. Now last one was the monopulse tracking method here. In case of the monopulse tracking, what will happen? Yeah, the name indicates mono pulse means what? Here it is using the single pulse here. For the tracking purpose, only one pulse is sufficient. That is the one of the greatest advantage of this mono pulse tracking compared to the previous ones. That is the conical as well as the lobe switching, because both required more than one pulse is there. Both the previous requires more than one pulses, but this one requires the single pulse here. This is the advantage of this mono pulse over those two techniques here. The monopulse uses the 4 antennas actually here, but the pulse is single, 4 antennas. A monopulse antenna is one of the method realizing the tracking the radar here. The word monopulse implies that with a single pulse, it can do that particular task here. The antenna may be the horn-shaped antenna here, and the elements are all stirred together and mechanical or electrical. All together, all the 4 antennas should be connected mechanically and electrically. The target is illuminated by all 4 quadrants equally here. Now see here, the main thing here or the basic principle here is, suppose this is the radar station here. Suppose this is the radar station. Suppose this is the station here. Here they are using, making use of the 4 antennas here. For example, here you just draw this section here. It is using the 4 antenna feeds here, horn type feeds. 4 antennas are there. This is 1, 2, and 3, and 4 here. Instead of only one receiving section here, it is having 4 here. 4 feeders are there here. Horn type feeders or the receiving sections are there here. Now what will happen? Suppose here the target is present here. First it will radiate the single pulse here. Mono pulse is radiated towards the target. It will strike the target here. It will strike the target and the echo signal is coming back. Echo signal is coming back. Then what will happen? This echo signal is striking on the 4 feeds here simultaneously. On 4 it is falling here, and depending on the strength of the echo signals received on the 4 positions here, all 4 positions, the particular location of that particular target can be analyzed here. For example, if you have received the signal like this, if it is received like this, means what will happen? Suppose this is the first one, this is the second one, this is the third one, and this is the 4th one here. Suppose the echo signal is falling like this, means what that indicates here? Here if you observe, on the 4th and 3rd, it is strength is more here and here. If you observe here and here, strength is more. Here compared to these two, it is little bit less, but here it is more less here. That is at the position 2. It is smaller strength is there. Therefore, we can analyze that the target position is, it is closer to the 3rd and 4th here. Like this, depending on the echo signal we are receiving here, depending on that pattern, exactly, suppose exactly circle we are getting, covering the same distance at the all the 4 quadrants, means what that indicates? The target is exactly at the center, because echo signals are falling on all the 4 parts simultaneously, in the same portion here, or the same amount. It is reaching to all the 4 feeds here. Therefore, we'll get this type of the pattern here. Now, depending on this pattern here, it will decide the location of the target. For example, this one, or like this you'll get. For example, suppose this is there, means like this. It is indicating in the 3rd and 4th it is more, but 1 and 2 it is less there. Therefore, depending on this, we can make out exactly at what position the target is there here. Now see here, just go through that diagram once again. Now you can observe here, that is, instead of 1, 2, 3, 4, it is A, B, C, D. The name given are, this is A quadrant, B, C, and D. Now if you observe here, it is exactly center here, because all the 4 quadrants are covering the same amount of the circle here. Therefore, this indicates the target is exactly at the center of axis of the antenna here. Now if you compare this one with this one, it is covering, the circle is covering more at D and C quadrant compared to A and B here. Therefore, the target location is towards D and C feeders here. Now here, if you consider here, it is covering more at the A and B compared to D and C here. Therefore, the target position is towards the A and B feeders here. In the same fashion, it is towards A and D. Here it is towards B and C. Again, it is more in the ADC but less in the B. Depending on these patterns received, exactly the target is tracked here or located, and continuously it can be followed here. This is the principle which is used in the monopulse tracking, and it is making use of the single pulse or only one pulse for the tracking purpose. But 4 antennas are used. 4 feeders, horn type feeders are there at the receiving antenna, and the echo signal is striking all the 4 feeders here, A, B, C, D, and depending on the strength of the echo signals or where it is exactly, it can be tracked. This is the basic principle. That is, suppose the sum of all the echo signals is A, B, C, D, all the quadrant. Now the azimuth error, that is the horizontal error, means A plus D, those two are added, and B plus C are added, and minus A plus D minus B plus C gives the horizontal error. And the elevation, vertical error, means A plus D minus C plus D here. That is, if you observe here, previous slide. This is A, B, C, D here, correct? A, B, C, D. Now see here. This is A and this is B. This is C and this is D here. Now suppose for the azimuth error or the vertical error, if you want, means these two should be added. A plus this is C and this is D here actually. A plus D minus this B plus C. That will give this azimuth error, and elevation error means what? This A plus B minus C plus D. This will give the elevation error here, and this is giving the horizontal error here. If you add these two minus this means horizontal error. Therefore, the sum is A plus B plus D. All the 4 should be added. That is gives the sum here, and the azimuth error means A plus D minus B plus C, and elevation error signal gives A plus B minus C plus D here. Therefore, we can find out the error signal and accurately we can locate where the target is present. Now this completes the antenna tracking method, and the related questions for this particular topic I have posted. All of you answer those questions in the assignment book. And in the next topic, we'll cover with the next session there. That is the next topic will be covered in the next session. Thank you.